Hi folks, how are you? Welcome to Complexity Unraveled. If this is the first time on this channel, we cover a wide range of topics from technology, megatrends, business venture, to macroeconomics and social issues. To put it differently, we are interested in topics that are complex in nature and of great relevance to the society. On this channel, no one will ask you to like, share, or subscribe. So please click on nothing, smash nothing, and buy nothing. If you share our interest in this kind of topics, please give us 15 minutes of your attention and we promise to make it worthwhile. In the first part of the video, we discussed the current state of 5G deployment. I hope we could provide some insight into the reasons why 5G still has not achieved the breakout success yet. In the second part of the video, we will pick up where we left off last time, starting with the lack of true 5G killer app, and then move on to what lies beyond 5G. Not to undermine the significance of a killer app that everybody is so desperately searching for, but we would like to offer a different perspective. 5G might simply become a necessity in some part of the world because of the technology advancement in other areas. You see, started in 2014, Japan is building a new high-speed railway system, the True Shinkansen, a gigantic infrastructure undertaking that will cost almost $100 billion. The old one, the Tokaido Shinkansen, runs along the coastline. But in the case of the new one, 90% of it will be digging through mountains and running in the tunnels. A truly marvelous engineering project. Upon completion, you can travel from Tokyo Shinagawa Station to Nagoya in 37 minutes with a traveling speed beyond 500 km per hour. And you cannot talk about high-speed train without mentioning China. In China, you have the new maglev going well beyond 600 km per hour. Some people might wonder, how does it have anything to do with 5G? Well, it changes everything. It changes the entire narrative. Even though it doesn't get a lot of attention and rarely discussed, connectivity in a high-velocity environment is a challenging issue. 4G's peak data rate could reach 1 gigabits per second, but only in stationary environment. When moving at 100 km per hour, the data rate dropped to 200 to 100 megabits per second. With increasing velocity, the data rate will further decline. At 200 km per hour, performance will drop another 35 to 80%. The technical specification doesn't even go beyond 500 km per hour. With advancement of high-speed ground mobility going well beyond 500 km per hour, 5G will become a simple necessity to keep us connected, especially in this hyper-connected future. I mean, this is kind of fascinating to just think about. In some parts of the world, the society is changing in such a way that people will actually need new technology to accommodate their day-to-day life. This is certainly not the killer app that would get people excited. But do we really need a specific killer app like in the case of previous generations? Even today, in crowded areas like stadium or concert hall, we are experiencing connectivity issues even with 1 or 2 mobile devices per person. In 2021, there are slightly over 12 billion IoT devices worldwide. And this number will increase to a whopping 500 billion by 2030, a jaw-dropping 40x growth in less than 10 years. That would be almost 60 times of the world population by then. How could that work without new technology backbone? In the age of hyperconnectivity with more than 500 billion connected devices, new capability of cellular network might just be required to fulfill our basic needs. I mean, definitely not sexy, but essential. Some people also suggest that 5G's killer app will be the 6G. It doesn't mean to be sarcastic. You see, the deployment of 5G high band requires extensive effort to densify the cellular network. And this massive investment in infrastructure could be used for decades. In that sense, 5G lays down the foundation for the future generations, which will likely operate above 100 GHz. It could use the 5G cellular infrastructure and the same fundamental breakthroughs in radio circuits and antenna technologies. Some people might argue, We haven't even reached a reasonable degree of 5G penetration yet. It's probably just too early to talk about 6G. Well, here is the thing. Mobile wireless communication technology has an extremely lengthy development cycle. The rule of thumb is approximately 10 years for each generation. Take 5G as example, even though the commercial rollout happened just recently all over the world, the development started as early as 2009. For 6G to become part of our life in 2030s, industry leaders like Huawei and Samsung have long started the 6G race. Even though the technology is still in its embryo stage, a glance into the 6G concept could still provide rich insights into this hyper-connected future. Looking at the past, the development of wireless communication technology, as we mentioned previously, is primarily matrix-driven. The simple advertisement of a new generation has always been like X times faster in download speed, X times reduction in network latency, X times more efficient in power consumption, X times improvement in whatever quality. I mean, you get my point. This matrix-driven paradigm is likely coming to an end with 6G. Purpose-driven will be the key to 6G development. Instead of building the technology and wait for the best applications to emerge, the development of 6G is done with value creation in mind from the get-go. 4G was about connecting people. With our smartphones, anywhere, anytime, we're connected with each other. 5G was designed with IoT in mind. It's about connecting things. This is a reason why massive machine-type communication is one of the key pillars of 5G. In the case of 6G, it's about connected intelligence. The proliferation of intelligence will be so quintessential for the future that 6G network will be designed for optimal AI and machine learning support, not only as a basic functionality, but shoot for the ultimate performance by running distributed AI at the very edge of the network. Truly pervasive intelligence will be the networked AI, not today's centralized cloud AI. I know all this sounds a little bit cryptic, and it's really hard to imagine a world as such. You see, we tend to overestimate what we could do in 2-3 years, but underestimate what we could achieve in 10-15 years. And this is the exact spot where we are at right now. In 10 years, in 2032, how would our day-to-day life look like? In that not so distant future, our life would play out in 3 different realms. The physical world, where real-life events take place. The cyber world, a massive, digitally constructed cyberspace. And the biological world, where the human being takes a central stage. 6G network would work as the connecting tissue that fuses all 3 realms together. In a hyper-connected world, 6G would be the foundation to augment our experience, our control, and our intelligence. 6 fundamental technology pillars of 6G will enable this future vision. Native AI, extreme connectivity, networked sensing, integrated non-terrestrial network, native trustworthiness, and sustainability. Let's go through them together and have a look into the potential use cases. Starting with native AI. AI application can be found throughout the 5G network, but is primarily used as an optimization tool. We already mentioned the significance of intelligence in the context of 6G. On the network level, 6G will shift from the centralized cloud-based computing to distributed learning network infrastructure and push intelligence to the deepest edge of the network. On the connectivity level, instead of module-by-module optimization, 6G air interface and network design will leverage end-to-end AI and machine learning to implement customized optimization, automated operation, administration, and management. In terms of connectivity, 6G could deliver the ultimate performance. 10 to 100 times performance improvement could be achieved across the board. The peak data rate could reach 1000 gigabits per second, that is 1 terabits per second, a 50-fold improvement compared with 5G. The reliability could increase 100 times with failure rate well below 1 in 10 million. Connection density could increase from 1 million to 10 million devices per square kilometer. The network latency could be kept well below 0.1 millisecond. Positioning could be performed with centimeter-level accuracy. 100 times better energy efficiency could extend battery life up to 20 years. And to deliver extreme connectivity, 6G is likely to utilize terahertz spectrum and even light spectrum. Terahertz frequency spectrum, wider bandwidth, and the massive antenna arrays will turn 6G communication system into a sensor network, which could provide an accurate picture of the physical world based on the transmission, reflection, and scattering of the radio waves. Traditionally speaking, sensing is achieved by dedicated devices, like radar, LiDAR, or cell phone positioning. Integrated network sensing could significantly reduce the cost, leverage the widely deployed base stations and user devices. Terahertz sensing even has the capability of performing spectrogram analysis to identify the constituent parts of different types of food, medicine, and air pollution. From low-altitude airships, high-altitude balloons, to solar-powered drones, companies around the world have been making efforts to connect the world, especially in areas where infrastructure is lacking. I mean, even now, 40% of the world population is still not connected yet. And 6G network will likely integrate very low Earth orbital satellite system to deliver worldwide coverage. Contrary to people's belief, low Earth orbital satellite could actually achieve lower transmission latency compared with traditional fiber over long distance. In addition to satellite, new radio nodes such as drones, unmanned aerial vehicles, and high-altitude platform stations will become an integral part of 6G network, functioning as mobile terminals. Data, as well as the knowledge and intelligence derived from data, is the main purpose of 6G network. In a hyper-connected world, cybersecurity, data privacy, and network resilience will be the foundation. Since 6G network will move towards a distributed architecture, a consensus-based model like distributed ledger will be highly desirable. As quantum computing continues to mature, post-quantum cryptography will be essential to safeguard quantum computing-based attacks. Sustainability is one of the core requirements of 6G. The goal is to improve the overall energy efficiency by 100x across the network. The potential technologies to achieve this ambitious target ranges from architecture, materials, hardware components, algorithms, software, and protocols. Novel concepts such as energy harvesting or network-powered devices could also open up new directions. I know talking about concept of a novel technology can be sometimes really abstract. So let's have a look at some potential use cases. As of now, many proposed 6G use cases can be seen as an extension of 5G use cases, such as autonomous driving, immersive VR, or industrial automation. 5G could handle these tasks, but 6G could perform at scale. Digital twin is like the poster child of Industry 4.0 and digitization. From 2016 to 2018, Gartner listed digital twin as the top 10 strategic technology development trend for 3 consecutive years. Major industrial corporations like Siemens, General Electric, BMW are all heavily invested in this technology. Today's digital twin technology connects the digital and physical worlds. With 6G, it would be possible to add the biological world into the equation and fully realize a complete digital twin of a human body. Of course, it would require more than just 6G. Advancements in areas like biology, life science, material science, bioelectronics would be equally important. And for that matter, more than 100 sensors would be required in the human body to accurately monitor important organs, nervous system, respiratory system, urinary system, musculoskeletal, and emotional state. It could predict diseases in advance, simulate operations, forecast effects of medications, accelerate drug research and development, and ultimately improve life quality. It's really fascinating to think about how we communicate with each other in 2030s. Zoom call will definitely not cut it. I mean, even today, companies are looking into technologies that could provide telepresence. But to be honest, they all look quite silly. High-fidelity hologram is likely the future of telepresence. And even though it sounds a lot like a concept straight out of sci-fi movie, it's actually not so far from reality. You see, to render a high-fidelity hologram over a mobile device with a 6.7-inch display would require approximately 11 gigapixels and at least 0.6 terabits per second data rate. And to render a human-sized hologram would require several terabits per second data rate. Once again, it will also require breakthroughs in other areas, mobile GPU capability for instance. Right now, in 2022, it's roughly 2000 gigaflops per second. To be able to render hologram, the mobile graphic capability would have to increase fivefold and reach 10,000 gigaflops per second. I'm not sure how you feel about this. My initial impression of 6G use cases was rather underwhelming. I mean, most of the use cases were presented as 5G use cases a while back. And now, all of a sudden, they become the 6G use cases. I'm not entirely convinced that the 6G development is such a paradigm shift compared with previous generations, or at least the purpose-driven part is not so evident for me. But on a second thought, just like 5G, 6G might just be necessary. Or to put it differently, 6G needs to finish what 5G sets out to do. For instance, 5G's peak data rate is well beyond 10 gigabits per second. But the user experience data rate is in the range of 100 megabits per second. That is more than enough to handle 4K video. But in the case of 8K, the required 200 megabits per second cannot be achieved consistently and reliably. It would be entirely possible to have a great XR experience in a private 5G network or entry-level experience as consumer using public 5G network. But fully immersive XR experience from anywhere at any time would require more than 400 megabits per second throughput. That is way beyond the network capability of 5G. I guess after watching this video, a lot of people might become less excited about 6G. But here's a small reminder. The world will become increasingly connected, not the other way around. Future applications will become more sophisticated and require higher network capability, even in the case of mixed reality as we just discussed. 5G and 6G, they're fundamental technologies that make a hyper-connected future possible. One day, mixed reality will replace our displays. Our digital replica will wander around in the metaverse, and everything around us will be connected and will be intelligent. That future itself might be the killer app we're so desperately looking for. Thank you for sticking around to the end. I hope the second part of the video could be of some help to you. Thank you for tuning in and take care.